Welcome to C# for Crestron programming. In this video, we will look at the concept of try, catch, finally in C#. This code block provides a mechanism to keep a program running regardless if a statement throws an exception, and the opportunity to determine, cause, and react to the exception. We will be starting with a C# console app .NET Framework project called try, catch, finally. Outside of the main method, there is a global variable, static int z, and a method called static void do the math that requires two integer parameters to be passed in on execution. The two integers are part of a division operation, and the result assigned to z. If this method is called from the main method and the result sent to console, we are able to see a successful program execution. Take this basic method as an example of any operation you could perform in code, be it checking for a value in an array or attempting to access a device that should exist in a program based on reading a config file. In either of these cases, there is a potential for failure. Here, if we inadvertently pass a parameter that causes us to divide by 0, an unhandled exception will occur. Unhandled exceptions cause the programs to stop executing. You will notice the process memory graph in the editor is no longer showing progress. In other words, our program has stopped. On a control processor, this would require a program restart or a reboot to recover. We can mitigate these issues by wrapping our code in try-catch blocks. Entering try and pressing tab twice brings in the structure of the try-catch. Within the try, you enter your code to execute and use the catch or multiple catch blocks to account for each type of exception that could occur. Throw is included in the catch block by default and is a useful statement if you wish to halt the program whenever it should not continue as a result of what just happened. Our catch block can be used to clean up resources, log errors, or recover from the exception, but in our case, we will write the error to console. Within the parentheses of the catch, we define an exception variable e to carry the exception details and use IntelliSense to access the message within. Note that the process memory graph is still progressing. It is recommended to provide individual catch blocks for each exception that you would expect. We will add a specific divide by 0 exception catch block and see what information we can get from the exception about where the issue came from. A generic exception catch-all at the bottom of the list can also be used to recover from and write to an error log, or deliberately throw an exception and stop the program as if we had reached this point. Maybe we should revisit our pseudocode. Catch blocks are read top-down until a match is found. With the try-catch in place, the console output, math result is equal to 0, is still being written to the console window, and the process memory graph in the editor is still in motion. This means our program is still running as the exception was caught. We can extend on the try-catch block to provide further resource cleanup or additional code statements by using a finally code block. The finally code block will run after the try-catch completes as long as there are no unhandled exceptions or a throw statement was reached. Here, we are ensuring that our output has a minimum value. As our programs become more dynamic with components changing at runtime, there is a greater potential for statements to work during one execution of the program and not work during another. Regardless if a small part of the program fails, we would still like the rest of the program to continue to function. Try-catch blocks can be nested, and their placement is critical to following complicated stack trace outputs to the source of runtime issues. Our current stack trace has 2 levels of information to locate the issue, but there could be dozens of levels in production code. Watch what happens to this output when our do the math method has its own try-catch. This is a much simpler stack trace to follow. If the internal try-catch was not able to catch the exception within the method, the outer try-catch containing the method would have. You have now learned about the concept of try-catch finally in C#. How these code blocks can be used to handle exceptions and keep programs running. And you have also seen how nesting of try-catch statements can increase their effectiveness. Thank you for watching.